Okay, we are back again at the AC 35 and Johannes Hupner's famous DIY inverter, along with my little thing here to hold the ribbon cable and then give me a little screw-in piece to get rid of this nasty nest of just junk. Really hard to deal with. Got a lot of cable that we're not using. This way I can hook up only what I'm using at the moment. Got everything working. I had some difficulty with this piece because this isn't set up. This top part needs to be over that way, and this goes this way, or just relabel this because our first wire on our thing here is actually wired. It's actually for pin number 2 and not 1. So this thing got flipped around. I thought I screwed something up, but I needed to get the 12 volt to pin number 24, which I didn't have. I actually was putting it on pin 7, which is not what we want to do. So I've been able to consolidate wires. I got a little bit heavier wires than the ribbon cable for these external wires. They'll be shortened up and everything. And I do have color coding that I'm going to go ahead and use. This is out of a wiring harness from a car. And, so that's what that is. So this here is the inverter. This is what they call an Olemex board. I guess that's where a lot of the information is stored at on that chip on the Olemex board. And it'll just wiggle off. So if you get a kit to do your own inverter, this is basically what it looks like when it's done. And then you have the Olemex board, and you can, if you don't have it pre-programmed and you have the right software and you know how to do it, you can go ahead and program it. I was successful at doing one. For me, it's not a very easy thing because I'm not a electronics or computer programmer type person. So I'm working on other people's work and seeing if I can actually put it together and make it work. And I did. And this was the original one that I had actually purchased that another guy put together, and then I bought one and built it, and that's the one that's up running. This one I toasted, and I had to replace this power thing here, and I have a resistor up here that is bad that I have to replace. Other than that, I think this is fine. And I still have another one unbuilt. So I just have it just in case, because since I don't know what I'm doing half the time, if I ruin it, I wanted an extra one. And so I have an extra Olemex board. I've already ruined 2 of these, and these are not cheap. Not terrible expensive, but they're not real cheap either. So anyway, that's what I have. I have the encoder set up now properly, which I did actually have it last time I ran this thing. And one of the issues I was running into last time when I was doing this is the bank of batteries was, since I normally say I bottom balance, well, I didn't balance these 2 12 volt packs, and I ran one of them low, and the battery started to puff out. I got it recharged, and the puffiness of the battery went away. So that was actually kind of interesting. I never saw that before. So the good news is over here, I'll just turn this just a little bit. So on the computer screen here, I am now able to we'll just go ahead and quit this. We're going to quit the browser and the program, and I'm going to plug everything in and get everything started. We're back at 24 volts. I was playing with it just a little bit ago at 12. And now we're back at the higher voltage. So don't mind my backside here for a moment. So I have power. And with power, not sure if you can see it, but there's a little red and green blinking button, and that's what you want. If it's just red, then something's wrong. And so now I'm going to plug this in to the USB and to the computer. So now the computer's set up, and now I'm going to run the Huebner inverter, which is a web application that's been built, and it's actually quite nice. And they did a couple of goodies for me. So now you start that, and then it'll start the Firefox web browser, and then open this up and gives you a warning that you're playing with high voltage stuff, and you agree I'm responsible for what I do. Nobody else is responsible for what I'm doing, even though someone else provided a kit for me to put together. So I agree, and now I'm here, and this gives me all the parameters that are now on the computer board. And so I've got a few little things set up. I'm not gonna mess with any of the setups. I just thought I screwed things up, but everything's working. But now, rather than going back into the Windows environment to turn this thing on, since I don't have the contactor key switch yet, I can just go to motor and start inverter, and it now gives me start auto 1 or manual run, sine wave, charger, and step down. So these are for the chargers portion of this if you're messing with that, and getting everything set up and working before you actually get it going in your vehicle. And so now I can just go to auto start, and the inverter's running. And so now I can take my little thing here, and you'll see, I think you can still see the motor. You still see the motor there, so I'm going to run this up real quick. And I'm just going to hold on to the throttle, just bring it on over here, and I'm just going to it jumps up a lot faster now that I got 24 volts, and that's what I like. 12 volts, it was a little bit lethargic, but not bad. Got up to 3,000 RPM without going into field weakening and going really weird. So that's my throttle control. And then regen. It's got a little bit of built-in regen there, and so that's working good. So now I'm going to go over to user. Nope, not user. Inverter. Nope. Motor. Graph. I'm going to go into the graph. So now we can see what kind of RPM I'm getting now with 24 volts. So I can start the graph. Just starting the graph, and now I'm just going to crank this sucker up, and we're going to watch it peak up. At 4,600 RPM, 24 volts. Stop that. Stop the graph. And then I can export the image and say OK, and an image comes up of that particular graph. So that's really cool. Then I can go into pulse width, pulse amplitude, frequencies. So we're going to do this one again. I'm going to do frequency this time, and we're going to start the graph. So graph is running. And I'm going to spin that up. You can see that graph move. A little bit more. Now we're running at a higher frequency rate than I was before, because now I have higher voltage too. That back down, and again we can stop the graph, export the image, and go. And we're again. So I'm going to see here frequencies, sensors. I'm not sure what this is here, so let's start that graph. I don't think it, I think it's going to be current sensor stuck up. So I'm not sure what it's picking up there, but we're going to stop that and export that. And it saves it as a PNG file. Battery. We're going to start the graph. Now we're going to see what happens here. Low voltage, so it's very hard to see. It's very bottom of the page. So I'm not even going to bother with that. I'm just going to stop it. It just barely tickled that. The other nice thing about this is we can go into the inverter. We can flash the flash bootloader, flash firmware, and AT type tiny 13 chip, compile from source, and remove ARM compiler. Gives you a little bit of wiring diagrams there. Gives you some information here how to do a IGBT test, all that stuff. So some of it's working, some of it's not that I'm aware of. And so we got a motor database. So I'm running in configuration that they put in that I sent them that will work with an AC motor. If you just plug it in and pick it, it'll put those parameters in for you. And so that's really cool. So I'm going to end this, spin this little puppy up. Oh yeah, I wanted to do a amperage. I'm not sure we're going to see that, so let me bring the camera up close. That up there, and that up there. I'm going to hook the clamp meter up to there. I'll turn that to amps, and you can see what the amp meter is reading there, hopefully. So a little better reading on the amp meter. So I'm going to turn this up, see what kind of amps we're gonna, kind of amp draw we get off of the IGBT module. Jumped up there a little bit. So that's off of the module. Next, I want to set this up so you can read it. That's just coming off the battery. Far less amperage coming off the battery. And you notice that 18 amp spike back in for regen. So that's where that's at. All three of these are doing about the same on the amperage, so I'm not worried about that. And frankly, I'm not worried about any of it at the moment because it seems to be working really well. There's 12 volts coming off of that one IGBT module. Coming off the main pack, we're going to do this. So I'm just going to show everything on what I did earlier. So we're going to fix this little guy here. See if we get a voltage reading here. So 26.23 volts. Just trying to get this thing set up to where I can okay, so let's go ahead and do this. Whoop. I don't have a real good clip on this sucker. It's only dropping down to 24, so that's not bad. We'll be done with this soon because I'm running out of power on the phone. So I need to see. Anyway, here we go. So we're just going to put this back here. So we could set this up. Not sure if my mug's going to get in here or not. The good thing about this with the inverter is you get to build your own, and you can build the power portion of the inverter how you like. It opens the door for people to put more power to one of these AC motors without having the confines of the Curtis controller or other controllers. And it opens the door for people who rewind motors. So you can take an industrial motor, maybe not as pretty as this, and rewind it to work better. Might be a bigger motor, might be a smaller motor for, let's say, a little motorcycle or something. So you could build a small power section, nice little inverter probably that would work in a motorcycle situation too, and do quite well. And the IGBTs up for those are going to be a lot cheaper. These ones are only 400 amp IGBT modules, but I can go all the way up to 1200 volts. So I could, in effect, with this setup, go run up to 300 plus volts on this thing and 400 amps. This thing's going to scream. This thing's going to go quick. It's not going to have super duper torque to it, but it's going to have good speed to it. But it would do good for the lightweight Volkswagen that we're intending. So I just wanted to give that to you. And also we need little current sensors on this thing have been replaced. I've got new ones coming that will handle the current that I want. The ones I want are going to handle, will be able to handle up to I think 600 amps continuous and 900 amps peak for the current sensors that I'm going to put in, because I have modules in the house that are up to 600 amps and 600 volts. So I could run this thing at a 192 volt system and 600 amps, and this will be a little powerhouse. So that's basically all. Right now we're basically at a point where I need to finish getting the adapter put on, so I need to loosen this up, push it back a little bit, get it tightened on there, get it balanced, and get it in the car and go from there. So at this point I'm going to just stop. We're not going to go any further on videos for this until it's in the car, unless something cool comes up in the meantime. But until then, I've got a few more leaf modules to balance, because we're going to be putting those in the bus where that's what's going to be running this. I do have the Curtis controller. We're probably going to use the Curtis controller until I get this all built and boxed and packaged up. It does have a water-cooled block on here that's already been pre-built and made. It works, as you can see by the little plastic tubes here. Gets a little bit warm if you run it without it right now, but right now I'm just running short runs, so it hasn't been a problem. And that's about it. And we'll talk to you later. If you do get one of these on yours, it happens to be the one from the United States and not over there, my DIY site shows that these are labeled wrong for this particular application. So I just labeled them different, like they should be. So this outside one's actually pin number 2, and then 1 and 3 and 2 and all that good stuff. So it's kind of funky there, but it works, and everything is working. And all it's got to do is get the key switch hooked up and a pre-charge, and that's my next project, is that pre-charge. So there might be a video on that, and we'll talk to y'all later.